Okay, so this is an objective that focuses on the Pythagorean theorem. There are some things that we already know about the Pythagorean theorem. The first is that we use it when we have right triangles, or any triangle that has a right angle. We label the right triangle in terms of the legs and the hypotenuse. A and B in the Pythagorean theorem represent the legs of the triangle, which A is the leg here, B is the leg here. They are the sides that touch the right angle. And C is the hypotenuse. It is the longest side, and it is the side across from the right angle. So we can see that it is not touching the right angle. And the Pythagorean theorem is a squared plus b squared equals c squared. So if we know information about two of the sides, we can find information about the third side using our Pythagorean theorem, as long as the triangle is a right triangle. So let's do some examples. The first example is, using this diagram, we want to find the unknown side, or find our x. So we have our right triangle, which means we can use our Pythagorean theorem, our a squared plus b squared equal to c squared. We can substitute any of the values in that we know into our formula. Remember, a and b represent the legs, or the sides that touch the right triangle, or the right angle. C is the hypotenuse. So we know that one of the legs is 4, so we could say 4 squared. Another leg is 6, so we can say plus 6 squared equals the hypotenuse, which is what we're trying to find, x squared. We simplify 4 squared to be 16, 6 squared to be 36, and then we can add those two, which gives us 52 equal to x squared. We want to find the unknown value, so in order to get x by itself, we square root. And this is going to be some review of our simplifying radicals. 52 is not a perfect root, so I need to factor this down. I know it's an even number, so I can divide it by 2. So I get 2 and 26. Which is another even number, so I can break that down and get 2 and 13. 13 is prime, so I'm stuck, and I can take out a pair of 2's. My 13 stays inside the roots, and that is what my value of the hypotenuse is equal to. The next example, still using a diagram to find the unknown value. Now this one, we have to use some other information to find the value. We notice that we have a right triangle, and again, we're looking for that hypotenuse, so we can use the formula a squared plus b squared equals c squared. I have a leg, which is 3, so 3 squared plus, and then my other leg. I'm not currently given the value of this leg, but using my tick marks and using the other properties of the diagram, I know that this side of my four-sided figure has to be 6, and since they are congruent, this is also 6, and now I have the missing information for my leg that I needed, and I could substitute 6 squared in, equal to c squared. And again, I just simplify and solve. I can solve 3 squared to be 9, 6 squared to be 36, equal to c squared. Add the two squares, so 9 plus 36 is 45. And again, I want to find my c squared, so I square root, and I do not have a perfect root, so I have to practice simplifying my radical. This is a 5, so I can divide by 5. And I have 9 and 5. 5 is prime, but I can break down 9 to 3 and 3. And there I have a pair that can come out of my root. So I end up with 3, the root of 5 is equal to my c. And in this case, I left c as a hypotenuse. I could have substituted x into the formula, but we do know that 3 root 5 is representing c. One final example is to find the area of the triangle. I have my diagram here. My base of the triangle is 32 feet, and each side is 20 feet, which means we know that this is an isosceles triangle. If I want to find the area of the triangle, I need to use my area formula. I know that the area of a triangle is 1/2 base times height. I know the base of my triangle, but I don't know the height. What I can do to find the height is draw in an altitude, which is a line that goes from the vertex of the triangle down to the base of the triangle, and this creates a perpendicular. Because my triangle is isosceles, I know that this altitude, or this perpendicular line, is going to cut my base in half. So if I do 32 divided by 2, that's 16. Now I know that this triangle and the 2 remaining halves are each going to be 16 each. And from this altitude, I now have 2 right triangles that I can use to help me solve for the height of the triangle. So if I use the information that I found, I know that this is 20 and this is 16, and I'm trying to find my height so I can substitute it into my area formula. So we can call the height the unknown. This is a right triangle, so we can apply the Pythagorean Theorem. A squared plus b squared equal to c squared. I have a leg of 16, so I can substitute that in for a. My other leg is unknown, so that will be my x squared, and I have the information for the hypotenuse. So I substitute in my 20 squared. When I simplify, I get 256 plus x squared equals 400. I subtract 256 to isolate the x squared term, which leaves me with x squared equals 144. To get x by itself, I take the square root, and that gives me x is equal to 12. Now, what we just found was this unknown value right here, which is 12, which is actually the height of our triangle. This problem was not asking us to find the height of the triangle. That was just required so that we could find the area, since the height is a required measurement for the area. So now we have all of the information we need. We know that the base is 32 feet, so we can substitute that in for base. And we found that the height is 12, so we can substitute that in for height. So now we can calculate for our area. Area is 1/2 base times height, which is 1/2 of 32 times 12. We get 192. Feet is the unit, and since we're finding area, it is feet squared. Okay, make sure you have this in your notes so that we will have these formulas and you will be able to complete some practice problems when we come back to school.